The PCO-7121 laser diode driver module provides from 5 to 50 amps of pulsed current at frequencies up to 1 MHz and compliance voltages up to 5 volts. With an expansive range of current, voltage, and frequency combinations, this versatile module is ideal for a wide range of OEM applications such as LIDAR, range finding, ADAS, imaging, and more. When more specific requirements exist, the PCO-7121 can be the perfect starting point for a unique solution for you.
Hello, my name is James Budai. I'm the design engineer for the PCO-7121, and I'd like to discuss that module today. So in the photo here, we have the module itself in the far left-hand corner, the control cable, and the manual. You can order extra control cables at any time using that DEI part number that's listed. Here is the top view of the board with the mechanical dimensions so you can design it into your OEM product. This module was designed to support many different laser diode packages. It supports the TO18, TO5, TO52, 5.6 millimeter, and 9 millimeter diodes. And you could solder either this optional strip line or laser right on the edge of the board where you see a rectangular pad. There's also a rectangular pad on the rear side of the board that you can put the positive and negative leads. So what does the 7121 do for you? The 7121 has an output current that varies from 5 amps to 50 amps. The user controls that with an external voltage source that's adjustable from 5 volts to 95 volts. That voltage is on pins 5 and 6 of J1. The output pulse widths are controlled with your external trigger source. You can either drive the SMB connector or J1 pin 1 and 2. When the system is operating, you can expect a 12 nanosecond rise time and a 10 nanosecond fall time. And the module is RoHS compliant. Here's a graph showing the typical high voltage settings versus current. So these are a starting place for when you first power up the instrument, and after it warms up, the current will stabilize and it will drop a bit for about the first 10 minutes, and then it will stabilize, and then you will have to increase the voltage slightly to get to your operating current. Here is a safe operating area. So you want to make sure that you're always operating the module below these lines. This slide is the same graph, and I just wanted to go through a quick example. So let's say you were going to drive 50 amps to a laser diode, and you wanted a pulse width of 200 nanoseconds. So if you're wondering, how fast can I operate this at? So you follow the x-axis at 200 nanoseconds, follow that up, and then see where it intersects the graph, which is the lower graph, and we go across to the y-axis, which is on a log scale, and see our frequencies about 12 kilohertz is where you can operate that. So setting up the instrument. So when you receive it, you'll receive it in a box. The module itself is in an ESD box. It has a control cable and a manual. There is an option to order IMON cable or a strip line cable, and you'll be able to see what those part numbers are in the data sheet. So connecting up the instrument. So J1 has all our control signals. Everything's color coded. So if you notice, red goes to where it's showing the trigger on the silk screen of the board. Orange is going to where it says positive 15, and blue is going to the high voltage. So we'll see those connected in the next slide. J2 is the optional current monitor. So we connect the red and black wire to our trigger source, the orange and black wire to our voltage source, and the blue and black wire to our high voltage source. So when you put all that together, you enable your voltage supplies and you enable your trigger source. Then here is the output looking at it with an IMON. I should note that you must have a load. You must have either a laser or a shorted load to be able to get any current out of the module. So you need to make sure you attach those before you try to operate it. Otherwise, you're just not going to have any current coming out. So what are some typical problems and solutions? If you don't have any output pulse, what could it be? Well, First off, you need to make sure your trigger source can drive a 50 ohm load. You can't just drive this with regular digital logic. It needs to be able to drive a 50 ohm load. Also assure the 15 volt and the high voltage are both present, and make sure there is a load installed and soldered into place. Another typical problem is what if the output current is lower than you expect. First off, make sure you're operating within the safe operating area graph. So recheck your operating point and make sure you're underneath those lines. And you might have to increase your voltage slightly because the system's warmed up a little bit. And so after 10 or 15 minutes, everything stabilizes temperature-wise, and you shouldn't have to adjust the voltage anymore after that. And one of the other problems is ringing on the output. You really need to assure that the laser is soldered directly to the printed circuit boards with the leads as short as possible. We're trying to eliminate any parasitic inductance. If that doesn't help, then what you're going to have to do is reduce your output drive current because your laser might have too much parasitic inductance in the package and you might not be able to get to the current level you would like.
The PCO-7121 is a powerful, flexible, affordable laser diode driver module that can jumpstart your design process and meet your OEM integration needs in manufacturing. Contact Directed Energy and find out how we can help you from lab to launch.